This lecture is going to cover section 2.4, which is more on slope. So we're going to continue the discussion that we started in the previous lectures on slope. And we're going to continue talking about slope and parallel and perpendicular lines. So let's start with parallel lines. If two non-vertical lines are parallel, then they have the same slope. If two distinct non-vertical lines have the same slope, then they are parallel. Two distinct vertical lines, both with undefined slopes, are also parallel. So let's look at an example. And then we'll plot them so we could see visually, that the lines are parallel. And it makes sense that parallel lines, right, are going to have the same slope because they're never going to touch, right? They're always going to run parallel. So they would have to have the same slope in order for them to never have an intersection. So let's look at example 1. Write the equation of the line that passes through -2, 5, and that's parallel to the line whose equation is y equals 3x plus 1. And we'll express the equation in point slope form and slope intercept form. So we want to write the equation of a line that passes through the point -2, 5. And it has to be parallel to this line, y equals 3x plus 1. Now, this line, y equals 3x plus 1, has a slope of 3, right? So then the equation of the line that we're trying to come up with also has to have a slope of 3, right, in order for them to be parallel. So we're looking for the equation of a line that has a slope of 3 and is going to go through the point -2, 5, and we'll call that point x1, y1. So let's use our point slope form of a line. So y minus y1 is equal to m times x minus x1. So we're going to have y minus y1, which is 5, is equal to m, which is 3, times x minus x1, which is -2. So we're going to have y minus 5 is equal to, let's distribute the 3, so 3x. And this minus, right, a -2 is positive, x plus 2, and 3 times 2 is 6, so that's going to be plus 6. So here's my point slope form of the line. Y minus 5 is equal to 3x plus 6. And now let's rewrite that in slope intercept form. So y minus 5 is equal to 3x plus 6. So let's add 5 to both sides. So we're going to get y equals 3x plus 11. So you'll see this equation of the line that we came up with has a slope of 3, right? It just has a different y-intercept than the line y equals 3x plus 1. So the fact that they have the same slope, they're going to be parallel, right? So let's graph them. Let's graph y equals 3x plus 1. And then let's also graph y equals 3x plus 11 on the same graph. So let me share my calculator. So let's graph y equals 3x plus 1 and y equals 3x plus 11 on the same graph. And we could see that these lines run parallel to one another, right? So let's do another example. Come up with the equation of the line that passes through 1, 6 and is parallel to the line whose equation is y equals 2x minus 3. So in order for another line to be parallel to this line, y equals 2x minus 3, they have to have the same slope, right? So we need to use a slope of 2, right? Along with this given point, 1, 6, which I'll call x1, y1, to come up with the equation of this parallel line. So let's plug into our point slope form. So y minus y1 is equal to m times x minus x1. So we're going to have y minus y1, which is 6, is equal to m, and we're using 2 because we want these lines to be parallel, times x minus x1, which is 1. So we're going to have y minus 6 is equal to 2x minus 2. So there's my point slope form. And now let's rearrange it into slope intercept form. So we have y minus 6 is equal to 2x minus 2. And I'm going to add 6 to both sides. So we're going to have y is equal to 2x plus 4. So again, my equation that I came up with, y equals 2x plus 4, it goes through the point 1, 6, and it's also going to be parallel to y equals 2x minus 3. And they have the same slope. So let's do the same thing. So why don't we plot these on the same graph, just so we can see that they're parallel. So we have y equals 2x minus 3 and y equals 2x plus 4. So let's graph them. So we have 2x minus 3, and then we have y equals 2x plus 4. And let's graph. And again, we see that we have a set of parallel lines. So it doesn't hurt if you were taking a quiz or a test or even doing homework, if you had to come up with the equation of a parallel line, you could always graph your answer and see that they're parallel. So now let's talk about perpendicular lines. If two non-vertical lines are perpendicular, then the product of their slopes is -1. If the product of the slopes of two lines is -1, then the lines are perpendicular. So the key with this is, so similar to with the parallel lines, right? We had to pay attention to the slope. So parallel lines are going to have the same slope. Perpendicular lines, if we take the product of their slopes, we should get -1. So let's look at example 2. It says, find the slope of any line that is perpendicular to the line whose equation is x plus 3y minus 12 is equal to 0. So I'm not asking for the equation of a line that's perpendicular to this one. I just want to know what's the slope of any line that would be perpendicular to this equation, to this line. Well, remember, two non-vertical lines that are perpendicular, the product of their slopes is -1. So let's rearrange. Let's look at what the slope of this line is, right? Let's get this in y equals mx plus b form. So I'm going to add 12 to both sides. So we're going to get x plus 3y is equal to 12. Subtract x from both sides. So I'm going to have 3y is equal to -x plus 12. And then divide by 3. So y is equal to -1/3 x plus 4. So all I did was rearrange this equation into y equals mx plus b form. Now I could identify the slope, right? The slope of this line is equal to -1/3. Now, any perpendicular line to this line right here, y equals -1/3 x plus 4, is going to have a slope that if I were to take the product of that slope and this slope, -1/3, we would get -1. So the trick is, take the negative reciprocal of the given slope, and then that's going to be the slope of a perpendicular line. So take the negative version of -1/3, which is going to be positive, right? I'm just negating the sign, and then take the reciprocal of 1/3, which is going to be 3/1, or 3. So the slope of any line that's going to be perpendicular to the line whose equation is y equals -1/3 x plus 4 is going to be +3. And we'll do an example where we have to come up with the equation of a perpendicular line, and then we could plot them. But any line that has a slope of 3 is going to be perpendicular to y equals -1/3 x plus 4. Example 3, let's write the equation of the line in A that passes through the point -2, -6, and is perpendicular to the line whose equation is x plus 4y minus 2 is equal to 0. And we want to express the equation in general form. So we want our line that we're trying to come up with, this perpendicular line, to pass through the point -2, -6. So think of that point as x1, y1. And in order for the line that we want to come up with, the equation of the line that's going to go to the point -2, -6, and for it to be perpendicular to this equation, or this line, we need to know the slope of this line. So let's rearrange the x plus 4y minus 2 equals 0 into y equals mx plus b form. This way we could see what the slope is. So I'm going to add 2 to both sides, and I'm also going to subtract x from both sides. So I'm going to have 4y is equal to -x plus 2. And then let's divide by 4. So I'm going to have y equals -1/4 x plus 1/2, right? If I reduce 2/4. So the slope of this line is -1/4. Now I want to come up with an equation of a line that's going to go through the point -2, -6, and is perpendicular to y equals -1/4 x plus 2. So the slope of the line that I need to use for this perpendicular line has to be the negative reciprocal of -1/4. So negate -1/4, that's going to become positive. And the reciprocal of 1/4 is 4. And it makes sense because look, 4 times -1/4 is -4/4, which is -1. And remember, the product of the slopes of perpendicular lines is -1. So now let's plug into our point slope form of a line. So we're going to have y minus y1 is equal to m times x minus x1. So I'm going to have y minus a -6 is equal to 4 times x minus a -2. So we're going to have y plus 6 equals 4x plus 8. So all I did was distribute the 4. Now we want to express this in general form. And remember, general form is ax plus by plus c is equal to 0. So we need to zero out, right, the right-hand side of the equation. So what I'm going to do is I'm going to subtract 8 from both sides, and I'm going to subtract 4x from both sides. So I'm going to end up with, let's write the x term first. So I'm going to have negative 4x and then the y term, so plus y. And then now combine the 6 and the negative 8, so it's going to be minus 2 is equal to 0. So that would be the general form of the line. That's perpendicular to x plus 4y minus 2 is equal to 0. And before we move on to part B, let's plot these lines so we can see that they're perpendicular. Now, in order to plot in the calculator, we have to have y equals, right? So we have to have it in y equals mx plus b form. So let's just look here, right, at this step. We had y plus 6 equals 4x plus 8, right? If I would have subtracted 6 from both sides, I would have been left with y equals 4x plus 2. So I can plot y equals 4x plus 2, and then y equals negative 1/4 x plus a half. And we'll see that they're perpendicular. So let's go to the calculator. So let's plot 4x plus 2 and 1/4 x plus 1/2. And I know it's kind of hard to see on this graph just because of the, pixels and the way it's kind of zoomed out, and the way the scale is. Actually, let's zoom 6, zoom standard. Yeah, it looks a little bit better. So we have the graph of two perpendicular lines here. And let's do one more example. So part B says, write the equation of the line that passes through 4, 2 and is perpendicular to the line whose equation is y equals negative 3x plus 6. And we want to express the equation in slope-intercept form, which is y equals mx plus b. So in order for the equation of the line that's going to pass through the point 4, 2 to be perpendicular to this line, y equals negative 3x plus 6, the product of their slopes has to equal negative 1. And we already know the slope of this line is negative 3, right? So take the negative reciprocal. This is like negative 3/1, right? The negative reciprocal of negative 3/1 is going to be positive 1/3. Right? Negate the sign. So negative is positive, and then the reciprocal of 3/1 is 1/3. So we're going to use a slope of 1/3 and the point 4, 2, right? We'll treat that as x1, y1. So let's plug in to our point slope form of a line. So we're going to have y minus y1, which is 2, is equal to m, which is going to be 1/3, times x minus x1, which is 4. So we're going to have y minus 2 equals 1/3 x minus 1/3 times 4 is 4/3. Now we want to get our answer into slope-intercept form. So let's solve for y. So we just need to add 2, and I'll do that in red, to both sides. So we're going to have y is equal to 1/3 x. Now we have to combine a negative 4/3 and 2, or 2/1, right? But we need a common denominator, which is going to be 3. So 2/1 is the same thing as 6/3, right? Because 6 divided by 3 is 2. But now I could add negative 4/3 and 6/3. And that's going to give me 2/3. So my slope-intercept form of the line is going to be y equals 1/3 x plus 2/3. And that line is going to be perpendicular to the line y equals negative 3x plus 6. So that's how we find parallel and perpendicular lines. The last thing that I want to do is let's interpret slope as rate of change. I know I've been stressing that, since we started this chapter, that we have to think of slope as a rate of change, but let's put it in context. So we'll look at an application question. And just a reminder, slope is defined as the ratio of the change in y to a corresponding change in x. So it's a rate of change. It's describing how fast y is changing with respect to x. So for a linear function, slope may be interpreted as the rate of change of the dependent variable per unit change in the independent variable. So we could think of it as the change in y with respect to the change in x. So this little symbol just means change. So let's look at example 4. In 2000, 11.9% of young adults live with their parents. In 2017, 22% of young adults live with their parents. Use this information to find the slope of the linear function representing young adults living with their parents. Express the slope to 2 decimal places and describe what it represents. So we're going to explain it in the context of this problem. So we're assuming that the relationship between the year and the percent of young adults that live with their parents follows, a linear equation, because I'm saying, use this information to find the slope of the linear function. So we can represent these 2 pieces of information as ordered pairs. So look, think of time or year as x. So x is equal to the year. And then y is going to be the percent of young adults that live with their parents. So we could write each one of these pieces of information as an ordered pair, right? So we could say, okay, X is year. So in 2000, 11.9% of young adults live with their parents. And we also know that in 2017, 22% of young adults live with their parents. Let me just rewrite this over. So 11.9. So we could think of these 2 pairs as x1, y1 and x2, y2. So let's find the slope of the linear function that would represent this relationship. And remember how we get slope. We take the difference in the y values and we compare it to the difference in the x value. So y2 minus y1 is equal to x2 minus x1. So y2 minus y1 is going to be 22 minus 11.9. And we're going to divide that by x2 minus x1. So 2017 minus 2000. So if we plug this in the calculator, so we're going to have 22 minus 11.9, which in the numerator is going to be 10.1. And then we have 2017 minus 2000 is going to be 17. And 10.1 divided by 17 is about 0.5941. And we're being told go to 2 decimal places. So that's going to be 0.59 to 2 decimal places. But let's describe what it represents in the context of this situation, right? So the slope equals 0.59, and we could put it over 1, right? Because we always want to look at it as a comparison or a rate of change. So remember, the numerator represents the change in the y values. The denominator represents the change in the x values. Y in this case represents the percent of young adults that live with their parents, right? And X represents the year. So this denominator of 1, and both are positive, right? So as one increases, the other one increases. So each year, right? So for every 1 year or every 1 unit that X increases, the percent of young adults that live with their parents is also going to increase, right? By 0.59%. Because remember, we're measuring Y in percent. So let's write that down. So each year, the percent of young adults that live with their parents increases by 0.59%. So each year, the percent of young adults that live with their parents increases by 0.59%. So that's the rate of change. As the years change, right? So as each year goes by, the percent of young adults that live with their parents also does, and it increases, and by that percentage. So that's how we interpret the rate of change in the context of a problem. And in this case, we were looking at time and percent of young adults that live with their parents. So this wraps up section 2.4, and in the next video, we will cover section 2.5.